Hey everybody, in this presentation we're going to look at how to do a linear regression in the TI84, TI83 graphing calculator. So I need to encourage you to look at the scatter plot video I made so you can see how to enter in the data and make a scatter plot, because to do a linear regression you have to have all the data in the lists, list 1 and list 2. So I'm using the same context of problem that I worked on before with the Department of Commerce per capita income for people in the United States from 97 to 2011. And I'm still calling X equal the year since 97. So when the year is 1997, X will be 0. And in 1999, the year will be 2. So I've got some easy list data to put in for my X data into list 1. And the salaries will be the Y data that goes into list 2. And so you would start here, but watch the video if you're not sure how to create the scatter plot or how to enter in the data. I'm going to show you that data really quick just so you can see. I'm going to the stat. Edit is already highlighted, and you can see my list 1, list 2 are already populated. My window dimensions are already populated to kind of fit this data here. And then when I go to the graphing tool, you want to turn plot 1 on, and that gives you a way to graph. So you just highlight, arrow, and enter if it's not on. But mine is on already, so I'm just going to click graph, and there is my scatter plot. Okay, so now we're ready to begin. The real thing here is creating a linear regression. The linear regression is a tool that will create for us the equation of the line of best fit. We can draw a line here and kind of eyeball it, but it may not be a very good line. The linear regression will give us the line that best fits this data. So let me give you an agenda of what's going to take place here. I'm going to show you how to do the linear regression in kind of a simple approach. Just power it out, get it done. Then we're going to look at how to graph the linear regression equation. Then we're going to talk about turning on the correlation coefficient. And then a more advanced thing, we'll look at how to save the regression into Y1, so it kind of helps us not have to write down so much information. But step 4 is, a lot of calculator sequence steps, which may not be worth it to you. Once you learn the simple approach, that may be good enough for you, and I'll let you decide that part of it. Okay, so let's begin the regression, and that's where step 2 will start us off on finding the regression equation. So we're going to go to the stat button here, and under the stat button there's a lot of menus. We want the calc menu this time. We're going to calculate something, so we're going to do the sideways arrow to pull up the calc menu. And notice number 4, linreg, that is of course an abbreviation for linear regression. So if we type number 4, that'll activate the linear regression command. So it's put the command on the command line. Now, those of you who have a newer operating system, you're going to see a window like this come up. And so to execute the linear regression, you're going to arrow down to calculate. And when you highlight calculate, then you hit enter. For the operating system that's slightly older, it just puts the linear regression command right on the command line. So I'm going to hit enter, and it's going to calculate the linear regression equation coefficients. And when you use the newer operating system and arrow down to calculate, you'll get the same exact values. Okay, so the simple approach is we're going to write this information down. What is that information telling us? It's telling us y equals ax plus b. For some reason they're using alphabetical order, but you know this equation from your algebra class as the slope-intercept equation, y equals mx plus b. So the graphing calculator is using the letter A for what we know as the letter m, the slope. So what the calculator has found, A, is the M. It's the slope of the best fit line. And B is the y-coordinate of the y-intercept point. So the B value is the same as what we know from our y equals mx plus b. It's just they switched us up here on the A. So when they use A, that's really M to us. So we need to write this down. 1124.089. I'm going to round it off to 2 values. So this is going to round off to 0.09 when I round that up appropriately. The B value is already rounded off to 2 values. So that's what I'm going to write into my calculator. And so now I'm ready to go to step 2. Writing the linear regression equation into the graphing feature. So let's click on the y equals, and we're going to enter in this best fit line equation, 1124.09 times x. That's my mx plus b, and my b number was 25,928.25. And now I'm ready to graph my best fit line. And you can see that best fit line goes nicely through the data. It's a very good line approximating those points. So that is the simple approach for finding the linear regression equation, or the line of best fit. And that's how you graph it. Now, some of your teachers may ask you for the correlation coefficient. And the correlation coefficient, R, gives us the reliability of the line. How accurate is our best fit line fitting the data? Now, this is a little complex because the older calculators don't give you the R so readily. But in newer calculators, you're going to go to the mode button. And if you see this next at the bottom of the menu, that means you have a newer operating system. If you have one of the brand new TI color editions, you're going to find much more on the mode command. And what we're looking for is diagnostics. The statistical diagnostics need to be turned on. So if you have the color edition, you're going to see statistical diagnostics right at the bottom. But on my calculator, the silver edition, I'm going to have to take the mode command here, and on this menu I'm going to have to arrow down to the next screen, and notice stat diagnostics. I need to turn those on, so I'm going to continue to arrow, get to the stat diagnostics, and I'm going to do a sideways arrow to highlight the on command and enter on. And now notice that the on command is highlighted, so stat diagnostics have now been turned on. And this is how you're going to display the correlation coefficient. So if we go to stat, calculate, number 4, and enter this time, not only do we get A and B, but we also get the R. And the R of 0.99 means our best fit line is really well-fitting line. You'll need to explore the details of what R means with your teacher, but I did want to show you how to find it because some of your teachers may want you to know what R is. Okay, lastly, recall with the simple approach, we had to take the M and the B and write them into the Y equals button manually. So what I want to do is show you a little trick on how you can bypass that. So what we're going to do is we're going to go to the stat command. I'm going to go to calc, number 4, pull up the regression, but don't enter yet. What we're going to do is add something here. We're going to add the y1 variable. And the way you do that is you're going to use this vars button for variables. Now if you have a newer operating system, you're going to do the same sequence of steps when you get to linear regression, except you're going to add it here. Store the regression equation. You're going to add it right there. So how you do that is you click on the vars, We want the y variables. We're going to do a sideways arrow, and particularly we want algebraic functions. So number 1 is highlighted, and we want y1. So we're going to store the regression equation into y1. And when I put y1 here, it's going to take the regression equation, and it's going to take the a and the b, or in reality, or the m and the b numbers, and it's going to type it into the equation for me automatically. Now when I go back to my y equals button, you're going to see a change. That's not the same thing I typed, because it's changed it for me. It put in all the decimals. Remember, I rounded it off? Well, when I put y1 into the command line, it stored the more accurate mx plus b numbers in here. So it saved me a step. When I graph, I get a slightly more accurate line. Anyways, that's something for you to explore. I hope that helps. Study hard in your algebra, and I'll see you in the next presentation.